Okay, so I'm going to do a couple more examples you guys have since we only got through one in class. So I have f of x equals x squared plus x minus 2 over x squared minus x minus 6. So the first thing I need to do is simplify. So I'm going to factor. So the numerator is going to be x plus 2 and x minus 1. And the denominator is going to be x plus 2 and x minus 3. So my domain is going to be what makes my denominator 0 right now, which would be x cannot equal negative 2 and 3. And then I'm going to reduce out my x plus 2's. So my x-intercept, I'm going to use just my reduced. So I have the numerator equal to 0. So x minus 1 equals 0. So x is going to equal 1. So my x-intercept, we write it as a point. My y-intercept is going to be zeros. So 0 minus 1 over 0 minus 3 will be 1/3. You can also put it into the original, be 0 plus 0 minus 2 over 0 minus 6, which should also be 1/3. So the point is 0, 1/3. It doesn't matter original or reduced on the y-intercept. So vertical asymptote is the reduced denominator equals 0. So x equals 3. Horizontal, we're comparing the degrees. I like to come back to the original. So 2 equals 2, so it's the ratio, so y equals 1 over 1. So it is 1. So now I'm going to graph what I have so far. I have an x-intercept at 1. I have a y-intercept at 1/3. So somewhere down there. I have a vertical asymptote at x equals 3. I have, it's not very straight. That's actually horribly straight. Try that again. Okay. And then I have a horizontal asymptote at 1. Okay, so now I'm going to do my interval analysis. And remember, intervals start at negative infinity, and they are broken up by vertical asymptotes and x-intercepts. So as I come across the x-axis, the first x-intercept or vertical asymptote I reach is at 1. And then I leave 1, and I hit 3. I leave 3, and I'm free to positive infinity. It should always start with negative infinity and end with positive infinity. So I pick some number. So I'm going to pick negative 1 for being less than 1. And I like to plug it into the reduced. It's just easier. So if I plug 1 or negative 1 in there, so negative 1 minus 1 is a negative. And negative 1 minus 3 is a negative, so the whole thing is going to be positive. So that means my graph is up here. But I know it has to be right here because I'm going to have to get to these intercepts. So it can't be above that horizontal asymptote. Okay, then I go to the next one. And 2 is between 1 and 3. So I plug it in right back up here again. So 2 minus 1 is going to be positive. And 2 minus 3 is going to be negative. So the whole thing is negative. So over here, it's going to be negative. And then 5 is bigger than 3. So 5 minus 1 is positive. And 5 minus 3 is positive. So the whole thing is positive. So it's going to be up here because there is no x-intercept right here, so it can't be here. So now I'm just going to draw my curve. Bright yellow. Let's see how that goes. I'm going to go along this asymptote through my intercepts and down towards my vertical asymptote. And then up here, I'm going to hug my vertical and then come down and hug my horizontal. And there's my graph. Okay, so the next example that we're going to do is 2x squared minus 5x minus 3 over 3x cubed minus 2x squared minus x plus 1. So the first thing we have to do again is to factor. So I need the factors of 6. Oh, let me get off yellow. The factors of 6 that have a difference of 5. So I have 2x and x. So I need 6 and 1. And then on the bottom, I'm just going to factor by grouping. Hopefully it works out for me. Okay, so I get x squared minus 1, so that would be x plus 1, x minus 1, and then x minus 2. It factored, but nothing reduces. But it is factored, so I can work with it. So my domain is that denominator set equal to 0, so x cannot equal, let's see, negative 1, 1, and 2. My x-intercept is my numerator equal to 0, so I'm going to have 2 x-intercepts here. So I'm going to have negative 1/2, 0, and 3, 0. My y-intercept is going to be 0s for all the x's, and I'm going to go back to the original because that's a lot. 0 minus 0 minus 3 over 0 minus 0 minus 0 plus 2. Okay, so my y-intercept then will be 0, negative 3/2. Good thing this is a sketch. Okay, vertical asymptotes is that denominator equal to 0. Okay, so x is going to equal negative 1, 1, and 2. And horizontal asymptote is, we've got 2 is less than 3, so it's going to be y equals 0. Start graphing those. I have a feeling we're going to have lots of intervals on this one. Okay, so x-intercept is at, I need to make some lines. Now remember, these are just sketches, so you just have to be close, not right on or anything like that. Okay, so we have an x-intercept at negative 1/2, and at 3, we have a y-intercept at negative 2/3, negative 3/2, and then we have vertical asymptotes at negative 1, 1, and 2. Oh, this is going to be lovely. And then we have a horizontal asymptote at y equals 0. So again, just putting it on the outside there. So my interval analysis is going to be negative infinity to negative 1, negative 1 to negative 1/2, negative 1/2 to 1, and 1 to 2, and 2 to 3, and 3 to positive infinity. Well, if I look at this graph already, I should know that it has to go through this x-intercept and through this y-intercept I should know that it either has to come up or down, so I got a lot of work to do. So -3. So that would be a negative, a negative, 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 negative. So I got odd negatives, so it's negative. So it's down
You
here.
brought your own rice.
It's afraid I'm just telling you like
So I know this
I
graph,
don't think it's enough to fill me up.
so we know this graph is right here.
I mean, I can say
This one should be positive. This one should be negative. So I need 3/2. 3/2 is going to still make this positive, negative, positive, positive, negative. So the whole thing's going to be positive. So this graph comes right here, down and up. And then we have 5/2 in between 2 and 3. So I have positive, negative, positive, positive, positive. So it's going to be negative here. So that means this one has to be positive. So the graph will come up through here and down and come back to this asymptote.